Hello everyone and welcome back. I hope the last lecture was clear to you. Now let's keep learning, shall we? In this module, we will start with fundamentals of Python. Basic syntax and variables. Naming conventions. We have to give meaningful names to our variables. Example, we can use snake case. Snake case refers to the style of naming where blank spaces are replaced by underscore. This is done for clarity and also because we can't use blank spaces in variable names. Basic data types. Int, which represents whole numbers, for example 5. Float, which represents decimal numbers, for example 3.14. Bool, which stands for Boolean values, true or false. 1 and 0 respectively can also be used in place of true and false. And finally, str, strings, that is sequence of characters, for example hello. Moving on, dynamic typing. Python is dynamically typed, so variable types are determined at runtime. This was briefly talked about in the first lecture. So here in Python, we don't have to specify beforehand what kind of data a variable will contain. Variable types can be determined when we run the program. Type conversion. This is of two types: implicit type conversion and explicit type conversion. Let's check this out. I hope you remember how to use the Python REPL. So let's say 7 plus 5.4. Now 7 is int while 5.4 is float. And the result 12.4 will be in float. So here Python automatically does it. We users have no part in this type of conversion. Similarly, we can write this will also give us float. Meanwhile, explicit type conversion, we want to convert 10, which is int, into float, which will give us 10.0. Similarly, we can do the vice versa. We can convert a float to integer. Now you see, 5.6 can be rounded off to 6, but that is not what happens here, right? So explicit type conversion just changes the data type. It does not give you the value of the nearest integer. Instead, it just gets rid of the decimal part. In case we have a number specified in quotes, we can also convert it to numerical data types. For example, here 5 in inverted quotes is a string. We can convert it to float and then we can use it in further calculations. Now let's talk about operators and expressions. Arithmetic operators: plus, minus, star, which stands for multiplication, slash, which stands for division, double slash, which stands for integer division as discussed in the first lecture, and percentage, which is also called modulus, which gives us the remainder of the division, and double star stands for exponent operator. Now slash operator performs division and gives the quotient. Double slash operator also performs divisions and gives the quotients but in integer. Modulus operator or the percentage operator performs division and gives us the remainder. Comparison operators: equal to, not equal to, which is written as exclamation mark and equal to, greater than, less than, greater than equal to, and less than equal to. Comparison operators are used for comparing two values. We write double equal to compare, while single one is used for assigning values. Logical operators: and, or, not. Logical operators returns value as per some condition. Assignment operators: equal to, plus equal to, minus equal to, star equal to, slash equal to, modulus equal to. Equal to one is pretty simple. This is the most used assignment operator and it is used in every programming language. Plus equal to actually adds some value to the already existing value of the variable. Similarly, minus equal to would subtract some value from the already existing value. Now let's write programs to understand these better. Let's see the difference between slash and modulus. 17 slash 3 would give us 5.66. 17 modulus 3 would give us 2. Now 2 star star 3, which means 2 to the power 3, would give us 8. Now let's check out comparison operators. Suppose A equal to 2 and B is also equal to 2. Here in this statement, we are basically asking whether A is equal to B or not. Since it is equal to B, the answer is true. But if x is equal to 3 and y is equal to 4, and if we print x equal to y, this will give us false. But if we print x not equal to y, which is written as exclamation mark and equal to, this will give us true. Similarly, x less than equal to y will also give us true. We can simply even write x less than y. This is also true. The way these operators are used may come as a surprise to someone who's not familiar with coding, but they are really simple to work with and also pretty easy to remember once you're familiar with them. Alright, moving on, just like comparison operators, logical operators also give the result as true or false, but in this case, the input is also Boolean. Now, logical operators can be better understood if we use truth tables. A truth table shows all possible outcomes of a logical operation. True can also be denoted as 1 and false as 0. Now, let's write truth tables for all three operators. Starting with AND, A and B are our inputs. In case both of them are false, so in the first case, both of them are false. In the second and third cases, one of them is true and one of them is false. While in the last case, all of them are true. These are the outputs that we'll get. So for AND will only give us true if both the inputs are true. So if A and B is true, then only we'll get true. Otherwise, in all the cases, we will be getting false. So this is something you have to remember. Similarly, for OR, I hope my handwriting is readable. If it's not, then you can comment down and tell me about it. In this case, we can get true if only either one of them is true. So if A or B is true, we can get true. So in this case, we will have only one's false answer when both of them are false. Now, AND and OR need two inputs to work with, while NOT requires only one. It will just give you the inverse of the Boolean value as a result. A bar is how we write inverse. So if A is 0, then A inverse will be 1 and vice versa. NOT is also known as negation operator. You can try writing truth tables on your own, and trust me, if you know the rules, which are pretty straightforward, it is very simple. Now let's see how we can use logical operators in programs. Suppose Okay, here true always has to be written with a capital T. Here I made a mistake. This is the format of writing true. Same goes for false. The first letter has to be capital. Now, printing A and B would give us false, since both of them are not true, and only gives true when both of them are true. Printing A or B, however, will give us true, since it gives true if either of them is true. Now for or, we can just write not space B. Like, since not only works with one input, and you also have to remember that A space and space B. Similarly, A space or space B and not space B. This is how we have to write it. And for not A, we get this. Moving on to assignment operator, we have already demonstrated the use of single equal to as an assignment operator quite a few times now. Let's use plus equal to. Suppose A equal to 5, A plus equal to 5. Now let's print A. A was already initialized by the value 5. Then we wrote A plus equal to 5, which added 5 to the already existing value. Then we get 10. So basically, this is the same as writing A equal to A plus 5. Now let's check again. This will give us 15. So A plus equal to 5 and writing A equal to A plus 5 does the same job. Plus equal to and similarly minus equal to or slash equal to could be considered smarter ways of assigning values. If B equal to 2 and we write it will give us 1. Since it is slash equal to, it gives us the result in float. Now let's move on to code in IDEs. Thorny and Replit are easy and free options. You can download Thorny from its official website. You can Google it, and this is the official website. It is available for Windows, Mac and Linux. Even its website is pretty simple to navigate. You don't even have to go look for the download section. It's right here. You can download whichever version you want from here. While Replit doesn't even need downloading, you just have to sign up and code in Python online. I have already an account here, so this is the page. If you do it for the first time, you have to select Python as the language and click on Create. We'll be using Replit for this lecture. Now let's learn about control flow. Control flow is the order in which individual statements or function calls are executed or evaluated. Now, if we don't interfere with the control flow, then the control flow moves from one statement to the other in the same order in which they are written. But in some cases, we might have to repeat the actions or even skip some. Instead of writing the same statement again and again, we could make the program execute the same statement with the help of constructs such as conditional statements, if, elif, else, and loops, for and while. Now let's learn how to use these. I have already logged into my Replit account. This is where we write the statements. Let's start with conditional statements. Let's say n is equal to minus 6. Now n is basically used for number here. Like when we write more programs, you will find out like whenever we want to enter a number, we usually use the variable n. It's simple and it's also, very much clear why we are using it. Let's implement the conditional statements. This is how we are supposed to write if statement. If space the condition and ending with colon. We also have to remember the indentation. In most cases today, the code, the platform which you are working on will already indent it for you. The indentation represents that the statements below if will only be executed if the if condition is satisfied. Now let's print positive. Now we want to enter a different condition. So we have to go back and this should be in the same line as if. Elif here is the comparison operator, equal to equal to. This is not the assignment operator, right? So if this condition is satisfied, the program is supposed to print 0. Now else. Now you can write else n less than 0, but you don't have to write it actually. Like since n greater than the 0 is positive, n equal to 0 is 0, you can just do this and move to print. Now let's run the program. Like since you have already mentioned the condition, like there's no specific need to write the condition here. You can write n less than 0 if you want to, but there's no need for it. In case you just have two conditions, you need not write the elif part. In some cases, you can even omit the else part too. Like for example, let's say the number is 6. And we don't want to check anything else. We just want to print positive. So here it is. You don't have to write anything else. Now let's see how loop works. Here's a very simple loop. This is the syntax for writing loop. For I in range, bracket, a number and colon. So a number, this basically represents 0 to 10. So number starting from 0 and less than 10. Running this will give us 0 to 9. So range, if you do not specify any starting value, it will start counting from 0 and it will go up to 10. It will not print 10. So this is something you have to remember. It's pretty simple, it just prints a straight line. We can also use while loop to write the same program. Let's say C is equal to 0. C stands for counter. Also, like C is always used for counter in many programs. You will see as we move on. Print C. Here we are writing this extra line. C plus equal to 1. Here we have used the assignment operator plus equal to. This gives us the same result, but here we have to initialize it. Like we are initializing C equal to 0 beforehand, then we are running the loop till C becomes 10. When C becomes 10, we don't run the loop. Then we print C, and at the same time, under the loop, we will be incrementing C by 1. So each time the loop runs, we will print C and also increment the value of C by 1. Now you can understand from these examples how we can change the flow of control using loops and conditional statements. Conditional statements are used to skip over certain statements. If the condition if is satisfied, we'll ignore the elif or else part and move straight to print. And if the condition is met in the elif part, then we move to print, skipping over the else part. In loops, however, we repeat the same thing over and over again. The repeated statement is really written only once, and the loop allows the program to execute the statement many times. Now let's see input and output. Input function is used to take the input from the user as a string, and then there's string formatting. This constructs strings dynamically by embedding variables or expressions within the string. Dot format is the older method and fstrings is the newer method, which can be used in Python versions 3.6 and later. Now let's check them out. Let's say n is equal to input. Let's say enter a number. Now this will give the user a message to enter a number. Now if we want to work with n again, we have to convert it into int, like since we are asking for a number. So this is what we have to do. We can use the same variable for both the input that we are taking from the user, which is a string, and then we can use it to contain the int value of n. Like both are n. So let's say, let's change the value of n minus equal to 1. Print n. Now Replit is very easy to use since you can see they are already giving you suggestions about what to write in the program. So it's very good for newcomers. So it's asking us to enter a number. So let's say 3. So 2. So 1 is subtracted from 3. Now we have to typecast the number 3 in order to use it for further calculation. Typecasting is, by the way, just another term for type conversion. Now typecasting will take another statement to execute. This one, right? To get rid of this, we can instead write it this way. We can do this. So this automatically converts the string that we have included, that we input, which is 3, into int. This will also give us the same result. Here it is. In the same way, we can take the inner float data in the form of a string and explicitly convert it to float in the same statement. This is an efficient way of coding. I mean, you wouldn't want to waste time dealing with your input before even beginning to work with it, right? Now let's learn string formatting. Let's start with the older method. Suppose course is equal to Python and lec underscore no is 2. This stands for lecture number, equal to 2. Here you see I've used snake case, which we learned in the beginning of the video. And this is also it's clear that what I'm trying to convey through this variable name. It's this lecture number. Now let's write new string course, second bracket, lecture number. Dot format course, comma, lec underscore number. You have to enter parameters in format. Parameters basically refer to the data provided as input. Here they are, course and lec number. Now let's print new string. Here it is. Printing course and lecture number separately would have given us just Python and 2, while printing this new string that we have created gives us much more information in a sophisticated arrangement. This is why we use string formatting. Now let's try the newer and concise method. Let's comment this line out. This is how we comment it, using a hashtag in front of the line. Commenting means this statement will not be executed or evaluated during the program run. Let's write this. This is the syntax for f strings. This will give us the same output. Here it is. In my opinion, syntax for f strings is easier to remember and reduces typing errors since we are just using alphabets and inverted commas here. While we are in dot format, we are using we have to write a longer line and we are using much more complicated syntax. Now we've come to the end of this video and it's time for a recap. We started off with naming conventions and basic data types. We learned about dynamic typing and type conversion, which is also known as typecasting. We learned about the different types of operators and their use in expressions. And we also learned to write truth tables to understand the working of logical operators. We learned about Tony and Replit. We learned about conditional statements and loops. And finally, we learned about input and string formatting. So this is the end of this video, guys. And also the second module of the course. I hope you enjoyed the video and I would love to hear your thoughts about it. You can comment down any questions you might have about this lecture or even the previous one. Any kind of suggestions regarding the course is always welcomed. Good luck to you and see you guys in the next video. Let's keep having fun with Python. Until then, bye-bye.